Hello everyone, today I'm going to be teaching you about redox chemistry and how to do reactions involving them. Firstly, when you have a redox reaction, you need to make separate half reactions. One of them should be what's being oxidized, and one of them should be what's being reduced. The second thing you need to do is you need to balance special atoms. So let's say we have nickel, or bismuth, or chromium. These are special atoms. They're not O's and they're not H's. So we're going to put them balanced in our equation. Then we are going to balance oxygen by adding H2O. So whatever side doesn't have enough oxygen, we're going to add H2O until the number of oxygens are equal. Next, we're going to balance hydrogen by adding H+. So we had H's added in the H2O. We need to balance them, so we're just going to add H pluses to the other side. Then, if you are in an acidic solution, you go to step 6. If you are in basic solution, we do this step 5. If basic, we add OH- to both sides equal to the H plus amount. When we do this, the side that had H pluses is going to form more waters, and the side that did not have H pluses is going to have OH minuses. Then, you're going to cancel out the number of waters that you have on both sides, and you will find that you will have waters left on the side that had H plus, and all the waters on the side that has OH minus are going to be gone. Then, regardless of if you're an acid or base, you're going to go to step 6. You're going to determine the oxidation state of special atoms. Then 7, you're going to add electrons to account for the oxidation and reduction occurring. Then in step 8, you're going to balance the half reactions to each other based on the electrons. And then step 9, you're going to combine half reactions and you're going to cancel out any duplicates. So if there's waters in both, you're going to cancel those. If there's OH minus or H plus in both, you're going to cancel those until it's only on one side. All right? Now I'm going to take you over to the other side of the room, set you down on this table, and I'm going to go through an example from the discussion, okay? Let's give me this to balance. Good enough. All right. So we have Cr2O7, 2 minus, plus I2 gives us Cr3 plus and IO3 minus. Let's lift that up. Okay. When we make these into these half reactions, we get this. And we find that in step 2, we need to make sure these special atoms, like these chromiums, are balanced. There are 2 chromiums here, which means I have to put a 2 in front of this chromium here. Okay? There are 2 I's here, so I have to put a 2 in front of this I here. Okay, simple enough. Well, now we need to add waters. Make sure our oxygens are balanced. So step 3. All right, I see 7 oxygens here. So we add 7 water here. I see 3 oxygens here times 2, 6. So I add 6 water here. Okay. Now, I want to do step 4. Let's take a look at our H pluses. Well, I just added a bunch of them, okay? 7 H2O. Okay, that's going to give me 14 H plus. 6 H2O is going to give me 12 H plus. All right, now the H's are equal on both sides. For argument's sake, let's say this is in basic solution. That way we can do step 5. So, in this top one here, I have 14 H plus. I'm going to add 14 OH minus to both sides. When I add it to this side, it just stays 14 OH minus. When I add it over here, these become 14 H2O. 14 H2O over here, 7 H2O over here, which means I can get rid of this and make this 7 H2O. Great. I'm going to erase it so it looks clean. So I've made 7 H2O over here. And I have the 14 OH minus over here, which I'll move closer. On the bottom one, same process. I have 12 H plus here. Let's add 12 OH minus here. And 12 OH minus here. Okay, now I've got both of those. Now I'm going to see that this stays here. These become 12 H2O. Great. 12 and 6. 6 is gone. 12 becomes 6. Great. Let's erase so it looks clean. 6 H2O over here. And over here, I'll just move it closer, we have the 12 OH minus. Okay. So So now we've gotten through the whole balancing of the O's and the H's. Now we need to look at our special atoms and see what oxidation state they're in. So for chromium, this side is pretty easy. Both of these chromiums have a 3+ oxidation state. Okay, fair enough. How about these ones? Well, we have 7 O's. Each O has a -2. That gives us 14. 7 times 2, 14. But our overall charge of the molecule is 2-. So we do 14 minus 2. That gives us 12. This tells us the amount of positives we have to have a molecule that has the 2- when we have 7 O's. So once again, I had 7 times 2 is 14 because each O is 2-. I have 2 more minus than negative. So 14 minus 2 gives me 12, the number of positives I should have. Okay, well I have 12, but I have 2 chromiums. So each of them needs to take half. So if I have 12+, each chromium is going to be a 6+. So what I've determined is I'm going to be going from chromium 6+ to chromium 3+. On the bottom one, I2, as well as N2, O2, F2, any of these things that are 2 and have nothing up here, both the I's have a 0, okay? Whereas the one over here, all right, we have 3 oxygens, great. 3 times 2 is 6. The overall charge is -1, so it's 6 minus 1 gives us 5, which means we're going to need to have a +5. Okay, so we go from 0 to 5. For consistency's sake, I'll put it on this side. A 0 to a 5+. Okay? Now we need to add electrons. So, in this top one, what are we doing? We are decreasing the number of positives. So, that means we are adding electrons, which means we are reducing the charge. So the charge started at 6+, it goes to 3+. Reduction. So, electrons are here. Electrons. How many electrons? Well, let's see. We have a chromium. Each chromium, and for argument's sake, I'll write this down here so it's easier to see. Chromium 6+ to chromium 3+. Each chromium is going to need 3 electrons because we do 6, 5, 4, 3. 6 to 3, reduction. Electrons are a reagent. Electrons, 3 of them, here. We have 2 chromiums though, Cr2. So we're actually going to need 6 electrons. That might be hard to see because the 2 is hidden in subscript here. But if you look at it from this point of view, it's not as hidden. It's a little bit clearer. Oh, clearly there's a 2 out front here. I'm going to need to multiply by 2. It still follows the same logic here. It might just be harder for you to see. Okay, so we find we need 6 electrons because each chromium needs 3, and we have 2 chromiums. Okay. What about our I's? All right, our I's, we have I0 going to I5+. Great. All right, I5+. Well, in that case, this is going to be an oxidation. We are losing electrons, okay? Which means they're a product. 5 of them to be exact. Okay? But this is only 1 I. We have 2 I's, which means we're going to have to add 10 electrons. Okay? So, I saw I needed 5, but I have 2 I's, so I need 10. So, having done that, we now have our electrons in the right spots. We can now balance these 2 equations based on electrons. I have 10 electrons in this equation. I have 6 electrons in this equation. Now, that's not quite lining up so nicely. The lowest thing I can get that has both those numbers in it is 30. You might have to work with some math to figure that out depending on the problem. So, we'll do 30. So, everything here is going to be multiplied by 3 to get to 30. So, we're going to have 30. 6 times 3 is 18. 2 times 3 is 6. 1 times 3 is 3. 12 times 3, 36. Up here, even more fun math, everything's multiplied by 5. 6 times 5 is 30. 7 times 5 is 35. 1 times 5 is 5. 2 times 5 is 10. 14 times 5 is 70. Okay. Now we've got everything ready to be added together. Now we can do the last step, adding the things together. So, 30 electrons plus 35 H2O plus 5 Cr2O72 minus plus 36 OH minus plus 3 I2 gives us 10 Cr3 plus 70 OH minus plus 6 IO3 minus plus 18 H2 plus 30 electrons. Let me see if you can actually see that on the recording. Oh, good, you can. All right, fantastic. And now we cancel things. 30, great. 30 electrons. We wanted that to cancel. Okay. Now let's do the H2Os. 18. This becomes 17. 17 H2O. This is not changing. That's not changing. 36 OH. 70 OH. Gone. 34. Which means our final is going to be 17 H2O plus 5 Cr2O72 minus plus 3 I2 gives us 10 Cr3 plus 34 OH minus plus 6 IO3 minus. All right, so after having done all of that, you can finally get something over here where you have waters on one side, OH minus is on the other side, and all of the other stuff adds up as well. Everything's balanced. Our work here is done. If you have further questions for me about how to do problems like this, feel free to stop by my office hours, and I hope this video was instructional.